what are we going to do for, okay, so for our countersunk hole, 54 in Y, 50 in X. 54 and 50, right? I'm going to put my drill in there to help me out as a pointer. Get it down near the surface where I can see. Turn off my X and my Y. Okay, 1/2 inch in X. Oh, easy turbo.
I got you.
Okay, so there's 1/2 inch in X. Lock the axis down. 54 in Y. Am I interrupting you guys? Okay, roger that. Lock my X. All right, I'm going to drill this dude straight through. Let's go ahead and get some RPMs, some rip'ems.
1.59. That's pretty close to this.
Yeah, it is. Wow, check you out. Okay, 3.82 times 100, because it's a high-speed steel drill, divided by 0.406 equals 940. There we go, 940. All right, start out nice and gentle. Actually, I think I'm gonna have to bring my knee up here. Gotta have enough travel. Okay, now remember, first just touch it ever so gently to leave that spot. Then once you get that spot, you can speed up a little bit. Now you just leave that little reservoir tip, fill it full of oil, and let's go through. Pausing to break chips. This poor drill bit has seen better days. Now that they're breaking, I'm just going straight. Oh, look at the colors changing. Come on, girl, you can do it. You can do it. Oof, I hope. My chips are turning bad colors, and I don't want to ruin my drill bit. Ah, I think I dodged a bullet on that one. Okay, grab the hot drill bit in your hand. Burn yourself. Let's chuck up my countersink. So get just the flutes in there. Okay, we got an interesting situation here, kids. So we got a couple things going on here. One of them being, I have a 3-flute cutter. Now the difference between a 3-flute cutter and a single flute cutter is the axial forces that I'm putting on it with this handle is being split amongst 3 flutes. So I'm not exerting as much pressure on the cutting edge. So this dude's gonna want to chatter. So I'm gonna calculate the RPM, but I'm probably gonna have to dial the RPM down because of the 3 flutes and my limited ability to feed those 3. So don't be surprised this thing starts getting angry. We got to slow it down. This is the first time this one's been used, so maybe we'll be lucky. All right, what RPM am I going to use? Oh, what happened there, Damon? What RPM am I going to use to set this countersink? All right. Here's the answer.
Damn, I think we got it.
You still working on the trig?
No, so if this is this what we're finding right here?
Yes.
Oh yeah, then we both got 0.212.
212.
212. Yeah.
Okay, sounds good. 212. Put a pin in that. Now to this. Now we got that figured out. What RPM, what diameter am I going to use for setting the RPM for this tool?
Outer diameter?
Yeah. And to answer the question, you have to ask yourselves, what diameter is the tool going to experience? Now, as I get smaller, the RPMs go up. But as it gets bigger, the RPMs must come down. So it is the large one that we want. So 0.78 is going to be our 489. 489. Thank you for calculating it. I'm not sure. Let's check your math. Yep, 3.82 times 100 divided by what was the diameter of this thing? 78. I got 489. Okay, cool. So let's, I'll go ahead and set the RPM since we're talking about it. Ooh, 489. Interesting breakthrough in RPMs here. I need to go into back gear. Back gear RPM starts at 500. So, get this out of the way. Back gear, I need to go in, back, and out. And now, when I go to turn this dude on, I have to go in the opposite direction. Let's dial up to 500 RPM. Woo! Okay. Now, so the motor's spinning fast. So now we're in a low RPM, high torque. This dude can twist this bit off. I hope it doesn't. That would really upset me. But now I need to do a accurate depth action here. And to do that, I need to work against the depth stop. So what I'm going to do is I'm going to leave it against this depth stop. I'm against it nice and hard. And I'm going to come up and touch off on this .406 hole. As you get close, slow down. I don't want to come hauling in here. Oh, oh. I'm hitting that part of the side. Take a look. Yeah, I'm going to call that good. All right, so I didn't want to blow into it, so I'm just barely kissing like half the hole right now. So now that I'm touched off against the stop, I need to raise the quill, get it out of the way, see if I can get down here for this little bit of witchcraft. Now I need to set the knee. Oh man, no light. No light. Well, that stinks. Ooh, maybe that'll, right there. So now I need to zero the knee. Oh, awesome. Good light there. What happened? I got my big fat head out of the way, I think. Lock the lock in. And what was the math we figured out for the trig? 0.212. So now I need to come up 212 thou. One trip around the horn is 100 thou. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Once again, 100. And then 12. 5, 10, 11, 12. That is the magic right here between locking that quill against the stop, zeroing, raising up that little trig dude we've got. Now all I'm doing is I'm drilling back to the to the quill stop. We've got a couple pictures of this here. All right, let's see how this dude's going to work. Going to get a better bite on that. I think I'm going to throw some love on it. And I'm going to drill down until I hit the work stop. Oh yeah, I'm digging that. Boom, that's it. All right, I'm digging that 3-fluter, man. That thing was nice. Okay, now it's time to check my work. And gonna get some air in there, but the air hose is back yonder. So I need to check the diameter of this countersink. And to do that, I have a countersink gauge. However, the quill's in the way. So I have to upset my Z to get here. So this kind of sucks, but I want to check it before I take it out.
Can you just change your X?
Okay, let's do that. Let's change the X. Good thinking. Really good thinking. Let's come over this way. Okay, so how this guy works is, if we look on the back, it says when this is zeroed, it is set to 12 thou. So what I do is I go down against a flat surface and I make sure this thing reads 12 thou. Now, this surface right here is stepped, so I would really go over to my granite and I got 12 thou. Okay, so it is set. So that's 0. So now that I go in here, I press down, and what I've got here, which one of you dudes am I going to be able to get in here? You? Yeah. I have little gauge, big gauge. So you see the little gauge, I'm rotating it a little bit, trying to find where this thing's at. So the little gauge is at 0.7, but not to 0.8 yet. You see that? So that is 0.7, and then I need to add this 78 to it. So I'm at 0.776. 0.776 is the diameter of that counter bore. How'd we do? That's not what I wanted. That's what I wanted. I wanted 0.78. 776. We're in good trigonometry, by the way.